everybody. This video is going to focus on the domain of composition functions. And essentially, we work with the domain of the second function. And what I mean by that is the function that's furthest to the right. So this is my second function. And the range is the set of, or is a subset of the range of the first function. So my first function is the one on the left. So these two functions, they both have a domain and range, but the composite function is a single entity. So it also has exactly one domain and one range. And when I say that it's a subset, what I mean is the domain of f of g is inside the domain of g. So f of g is inside the domain of g. Okay. So let's kind of look at an example. And here's what we want to do with this. We want to find f of g, g of f, and we also want to find their domains. Well, what I'm going to do to start off with is I'm going to actually find the domain and range of both f and g. So the domain of f, well, this is just a quadratic function, and we know that that would be negative infinity to infinity. The range of f, since this is a quadratic function and our leading coefficient is positive, we know that this has a maximum. We also know that the lowest value in this particular quadratic function is right here. So we go from 3 to infinity. The domain of g, it's a cubic function. We know that's all reals. And the range of g, well, the range of a cubic function is also all reals. So here's our domain and ranges of the original function. Now, let's see what happens. Well, first we're going to find f of g. So f of g of x. Well, we know that what we're doing is this value goes into this function, and then this answer, whatever it might be, goes into this function. So essentially we're taking f, which is 2x squared plus 3, and we're putting g in place of the x in f. So this would be 4x cubed plus 1. Now, let's carry this out, and let's simplify it down. So here I can expand that out, and that would be 2 times 16x to the 6th plus 8 x cubed plus 1, and then plus 3. We can then also distribute. And that will give us 20 x to the 6th plus 16 x cubed plus 2 plus 3, but honestly, let's just go ahead and instead of writing 2 plus 3, let's write 5. So, plus 5. Okay. Well, let's talk about the domain. So the domain of f of g. It's going to be a subset of this domain. And we ask ourselves two questions to be able to figure out what the domain of f of g is. First question that we ask ourselves is, does the domain of g have any restrictions? The second thing we ask ourselves is the range of g in the domain of f? Okay, so the domain of g is this negative infinity to infinity. It has no restrictions. The range of g is negative infinity to infinity. And that entire range is the domain of f. Therefore, the domain of f of g is just negative infinity, comma, infinity. All real numbers. Okay, let's find now g of f. Of x. So, g of f of x. What we are doing is we're taking f of x and we're putting it into g. So 4x cubed plus 1, and the domain of, and f of x is 2x squared plus 3. Okay. And we can simplify this down. It would be 4 times 8x cubed, 8x to the 6th, plus 12, 30, 36, yeah, 36x to the 4th, plus 54 x squared plus 27. And then we're still adding plus 1 at the end. So if we distribute, we get 4 times 8, which is 32, x to the 6th, plus 4 times 36. Okay, well, 4 times 40 is 160. 160 minus 16 is 144. So 144 x to the fourth plus, and then 54 times 4. Well, 50 times 4 is 200. 200 plus 16 is 216. X squared. 27 times 4, well, 20 times 4 is 80. 7 times 4 is 28, so 108. 108 plus 1, but just like last time, we are going to just do the 109. Okay. So what is the domain of g of f? Well, we look at our domain of f. It has no restrictions. We see that the range of f is entirely inside the domain of g. So the domain of g of f is negative infinity to infinity. The range of g of f we're not really concerned with. Okay. I do have one more thing that I want us to look at in this video. One more example, and that's this. Here we're not actually putting the function together. We just want to know what is the domain of f of g. So let's first find the domain of g. Well, the domain of g is x such that x cannot equal 2. Reason being, x minus 2 cannot equal 0. The range of g, well, the only restriction we have is that this will never actually equal 0. So it's x such that x does not equal 0. And that's because the numerator will never equal 0. The domain of f is all real numbers such that x does not equal negative 4, using a similar logic to this. And the range of g is x such that x cannot equal 0. Okay. This information will allow us to figure out what the actual domain of f of g is. So, first we look at the domain of g. It has a restriction. Specifically, x cannot equal 2. Okay, so that's part of our domain. Now let's talk about the range of g. Is negative 4 in the range of g? The answer is yes, which means we need to figure out what x value gives us a negative 4. Because if we get a negative 4 here, we would have to put the negative 4 into f, and that is not going to work. So, negative 4 equals 4 over x minus 2. We can rewrite this to be x minus 2 equals negative 1. And that will give us x equals negative 3, which shouldn't be, yeah. Nope, not negative 3, not negative 3, positive 1. I can do math, I promise. X equals positive 1. So that means that our domain also does not have 1 in it. So we look for the restrictions in the domain of G, then we look for the restrictions in the domain of F and compare that to the range of G. Okay, that is it for this video, and I will see you